video of the LeetCode series, that is longest palindromic substring. So today we will solve this problem and see what's optimal approach for solving this problem. So we need to find the longest palindromic substring of a given string. So we will be given string s and then we need to return what is the longest substring possible, which is a palindrome. So let's understand what is palindrome. So palindrome is the string which reads same forward and backward. So for example here BAB or ABA both are palindromes because if we reverse the string it will be exactly same to the original string. So these are called palindromic substring. But from the given string we need to find the maximum possible palindromic substring here. So for example if we consider Racecar, so it's complete palindromic substring. So here the string itself is a palindrome, so the output will be Racecar itself. And similarly we can check for this string, it's a palindrome. So how we can approach this problem? So there are two approaches possible. First is like the brute force solution, where we try to find all the possible substrings in the given string, and for each substring we check whether it's a palindrome or not. So how we can check it's a palindrome or not? So what we can do, like to find whether a string is palindrome or not, we can take the two pointer. First pointer will be on the start of the string, that is 0, and the last pointer will be to the end of the string, that is length minus 1 index. Okay, so uh, we check in a loop that if left pointer is smaller than the right pointer, and if it is smaller, then both the characters at each pointer has to be same. If it is not same, then we return false, and if it is same, then we check for another character. That is, we will check like the left pointer will move one step ahead to the right, and right pointer will move one step back, that is to the left, and this loop will continue. If this loop is exhausted, that means all we find a palindrome and we will return true. So for example, in the given string, let's say race car, we will start with left pointer on the first and right pointer on the r. So if these two characters are same, we will move to one pointer of left to the right, and one right from one pointer left from the right. So next character will be a and a. We will check that and do the same. Then we will check for c and c, both are matching, then we will proceed. Now at when it will come to e, then it's not the same pointer. Here the condition will break because we need to check when it is strictly lesser than the right pointer. When it has reached to the same character, then of course it has to be palindrome. So here we could have like done the equality sign as well. That will also work, but it's unnecessary. So here we can calculate the given string is palindrome or not in of n time, that is a linear time. So we need to scan the entire string once, so it will be of n complexity. And how do we find each substring? To find each substring, we need to create a two nested loops. That will be like first pointer, and the second pointer will start from the j is equal to I. So this will iterate like to each and every starting point of the string, and this will indicate the ending point of the string. So first we will start from I, and it will go till end of the string. Okay, so using these two nested loops, we will try to find a substring, and then we provide that substring to the palindroming function to check whether the given substring is palindrome or not. and if it's a palindrome, then we assign that the longest substring we have found is this. So we will check like the whatever palindrome we have found till this point, is it the longest or not. So we keep comparing this length. If this substring length what we have currently found is greater than the already found substring, then we will replace this longest substring with the given substring, like current substring. So at the end, we just return the longest substring. But this is a brute force approach where the time complexity is n cube, where n is the length of the string. So this will not work. There is a more optimal solution, which is an n square solution, where we will try to expand in the center. So what we what we will do is like for each character we consider that this is the mid of the palindrome, and then try to expand on both the side till we can get the maximum length possible. So I will show how it will work. So let's say I am considering that A is the center of my palindrome. Then what we will do, we will try to expand both on left and right. So here, when the starting index is A, left boundary will hit. There is no character here. So A will be only substring possible here if we try to expand at A. So next what we can do is B. So B has one character on the left and one character on the right. So what we will do, like if we consider these two, like AB as a single unit, then there is no character on the left of AB, right? So AB cannot have like more than two length solution here. So A is not equal to B. That means we cannot expand around AB as a whole. Why we are doing this? Because palindrome can be of two types. First is like odd length, where the middle character can be anything, and it can second type is the even length. So for example here it is a even length palindrome, right? So both characters will be same. So we need to expand around this. So let's say there was C instead of D here, then C B B C would have been another palindrome. So we have two options: either expand around single character or try to expand again around two characters. Okay, if both are same. But here it's a different case. So here middle element, this is a odd length string, right? So middle element can be just one character here, and then we can try to expand around E, right? Here it will be different case. We cannot expand around B, just one B, because here B will be different, here it will be different. So there are two possibilities. Try to expand around two characters, or try to expand around just single character, and both cases are possible. So here A is not equal to B, so we cannot expand around like both the characters combined. So what we try to expand is around just single character B. So on left there is one character, and on right there is one character, and this is equal. So this is a valid palindrome, and we cannot expand beyond this because there is no character. We have hit the left boundary. So this is one solution we have found. Then we try to expand around BA. Both are different characters. We cannot expand. Then we try to expand around A. Here B and C are different, so this is not possible. Now we try to expand around A plus A and C. Both are different. We cannot expand around this. Now we try to expand around C. It is same. then B is same, then A is same. So here the maximum length we have found is 7, which is better than the previous ABA, which is of 3 length. So we'll update the solution, and this will be our final result. But we will keep continuing because we don't know if we can find a better solution afterwards. So we'll try to expand around C and A, not same. So we'll stop here. Then try to expand around this single character A. C and B are different. We cannot go beyond. Similarly, we cannot expand around A plus B combined because both are different characters. And single character B we can expand on left and right we are same. So this is valid solution, but the length is still smaller than what we have previously found, which was 7. So we will not update this. So finally we have the best answer, and similarly like this. So this was like the dry run of our expanding around the center solution. Now let's look at the code how it will look. You can do similarly like dry run. This will also give the same result. See, so it's a similar example. So what we can do is we will try to expand around the center and see what is the final answer. So we will write a function which will accept a string, and we'll check for the edge cases like if it is null or it's an empty string, return empty. Then we will have the start pointer because we need to return the substring, right? So this will be used to track like the start of our palindrome which is of maximum length. So current length, max length will be 1. See, if a string is not empty, then definitely there will be one length palindrome possible because single character itself is a palindrome. That's why we are starting max length is 1. Now what we can do, we can write a function which will try to expand around a pointer and check whether it's palindrome or not. So here we will do the same. So these are the boundary cases check. If we are reaching the boundary, then we need not expand further. Else, what we will do is we will try to check both the characters are same. Then keep on expanding. Left will go further left, and right will go further right. So we'll keep doing this, and once we have found any different character or we have hit the boundaries of the string, then we will stop, and whatever is the length we have found, we will return that. So this will return the length of the given palindromic substring. So here what we will do, like for each character we will try to check whether if that character is uh, we will try to expand around the single character first, and then we will try to expand around the two characters combined, because we saw, right, like we can expand around a single character that will give odd length palindrome, and if we try to expand around the two characters at the same time, so that will result in even length palindrome, and maximum can come from both any of these, right? So we need to check like which is giving the maximum, and then we have like global max length, which will store the length of the max length of the palindrome found till now. So every time we will compare that the current palindromic length is more than the existing, like whatever best we have found till now. If it is more, then we update max length to the given length, and then we need to find the start of the palindrome. So this is important, because at the end we need to return that substring, right? So every time we update the max length here, we also need to update the start point, like from where that current palindrome is going to start. So that will we will get from this formula. So I is the current index, right? I is the current index, and length is the length what we have found till now, right? So let's say if I say here, for example, if I have to say like this is the given string, and this was the max length, right? So index will be 3 here, and max length will be 1, 2, 3, 4, 5, 6, 7. So 7. So its start will be 0. How we can find it? Uh, so basically, if it's a odd length, right? Odd length here, then we need to subtract 1 and then try to divide by 2, because if it's a odd length, like exactly half uh, characters will be on the left and exactly half characters on the right. So if we subtract this character from the entire length, we will get like half the length of the palindrome, like that is 3. So I minus 3 will be 0. So we'll get the start of this. But if it was, let's say, even length palindrome, then what will be the condition here? So for example, we'll check for this BB, right? So I will be this one, right? I will be this, and the length will be 2. So 2 minus 1 divided by 2 will give us 0. So I minus 0 will keep us on the same index. So that's how this formula works. So this will give us the start of the palindrome, and then finally we have both the start and the length of the palindrome. So we can easily return this substring. So let's see what's the time complexity here. So time complexity will be n square here, because we are checking for each character, like we are expanding around each character, uh, and this will contribute like n for the first loop, and then we have to expand around that character, which will contribute another n. So final time complexity will be n square. So this is explained how it works here. So brute force approach is n cube, and expand around center is n square. There is one more algorithm called Maneker's algorithm, which can solve this problem in of n time, like that is the linear time complexity. But it's not asked in interviews. Like in most of the interviews, we are expected to solve in n square. But we can cover this algorithm in some separate video. But hopefully you have understood this explanation. If you have any doubts, please comment in the video and I can reply back. Thank you so much for your time.